Welcome, geometry students. Today we're going to learn about solving triangles using the law of sines and law of cosines. Now, yesterday we focused on the law of sines, and today we're going to look at the law of cosines. So we're only looking at part of this target today. Alright, so the law of cosines is similar to the law of sines in the regard that you can use this for all triangles. It does not have to be a right triangle. So this law of cosines will work for right triangles, acute triangles, and obtuse triangles. The other thing that's the same as the law of cosines is how we label our triangle. So for example, angle A is always going to be across from side length A, and angle C is always across from side length C, and finally angle B is across from side length B. So that works the same. Also, the same as law of sines is the fact that this is indeed using capital letters for the angles and lowercase letters for the side lengths. Now let's talk about these three formulas. These three formulas essentially are the law of cosines, or at least a variation of the law of cosines. So essentially what we have is you pick which one of these you're going to use based upon the information you have given. So the way that you'll choose is to find what you need to find. So you need to choose the formula that will give you one variable, not multiple variables, and allow you to find the unknown value. Now if you look, it kind of starts looking like Pythagorean theorem. So I'm going to start with the bottom. It says c squared equals a squared plus b squared. So essentially that's Pythagorean theorem. And then they take away 2 times ab. So it's always going to be take away 2. If you look here, it's always minus 2. And then 2 times the product of this side length and this side length times cosine of whatever angle is across from this particular side length. So again, if we look at this in terms of another wording, or another way to write it, you have a squared equals b squared plus c squared. So whatever variables by itself, you square that equal to the other side length squared plus the third side length squared. The big difference between this and Pythagorean theorem is we don't have to worry about that being the longest side length. That can be any side length, shortest, medium, or longest. And then continuing on here, we take that side length squared and then the other two side lengths squared and subtract 2 times BC. So it's always minus 2 times this side length and this side length. If you notice though, there's no squared here in the product. And then it's always times cosine of the angle that's opposite this side length. Now, I know that's a lot. We'll talk about that more in class tomorrow, but let's just think about how we can figure out which formula to use. Okay, here's our first example. I've started by drawing the picture, so if you would like to read through it and make sense of that, please do. Go ahead and pause the video to do that. Okay, so hopefully you agree with how I set up my picture, but if you had trouble setting that up, just as a reminder, we don't know what kind of triangle this is, so we just kind of drew an arbitrary triangle, and we made sure that the side length was opposite the angle measure. So for example, segment F had to go across from angle F, segment D across from angle D, and so forth. So that was the key here. We're finding the measure of angle F, and we're approximating our answer to the nearest hundredths. Now if you look back at the formulas we saw here, I'll erase all of those markings. None of them deal with D, E, or F. So we kind of have to just use the law of cosines and create the formula. We want to find F. So in order to find angle F, we have to use a formula that deals with side length F. So whichever formula we're going to use, the ending is going to be the cosine of whatever angle I want. Well, I want cosine of angle F. So I'm going to have my beginning amount be side length F. So the key is that this angle has to match with the side length that it's across. So I have equals, well, the other two lengths are D and E. Okay, so this is my side length equals D squared plus E squared, and then I take away 2 times whatever these two lengths are. So 2 times D times E times the cosine of f. So that's how we came up with that formula. That's probably the hardest part right now, but don't worry about that piece. Now let's look at how to manipulate the formula. So let's put in the information we know. Well, we know f to be 19 centimeters. So 19 squared is equal to d squared. We know d to be 11 centimeters. So 11 squared plus e squared, which is 17 centimeters, so 17 squared, minus 2 times dE. So minus 2 times, and then it's always going to be these lengths, but not squared. So 2 times 11 times 17 and times cosine of f. Now, if you get to this point and you have more than one variable in your problem, you have a problem. You won't be able to proceed further. So what you need to do is make sure you have just one single variable, and we do. In this case, we're going to manipulate this formula to find angle f. Keep in mind, cosine is not an unknown. That's just an operation we're going to be using. Okay, so now we need to think about some algebra. Back to solving equations. Well, we have 3 terms on the right side. I have the 11 squared term, 17 squared, and then this is all one term. So all I'm going to do is simplify my terms at this point. So 19 squared should be 361. 11 squared is 121. 17 squared is 289. And then what we're going to do is simplify the last term. So we're simply working with the product of 2 times 11 times 17. Well, the product of 2, 11, and 17 is 374. If you notice, I did nothing with the cosine of f yet. I'm not working with that yet. Okay, now just like any other problem, I'm going to simplify like terms. So when we solve equations, like terms means they have to have the same variable part. Well, the only variable piece we really have, and it's not technically a variable, but it's this cosine of f. So that term is not like these 2 terms. So I'm going to combine the terms 121 with 289 since those are like. And when I do that, I end up with a result of 410. Now again, I'm going to bring down the minus 374 times the cosine of angle f. I cannot subtract 410 minus 374 because those terms are not like terms. So I'm going to undo my 410 by subtracting 410 from each side. So 361 minus 410 should give me a result of negative 49. Okay, now I just want to take a little sidebar over here. You don't need to write this down, but just a quick reminder for algebra. If you have 5 is equal to 10x, we solve that by dividing by the coefficient of x, and we know that x then is 1/2 or 0.5. Well, we're doing the exact same thing over here. The coefficient of the cosine of angle f is negative 374. So we're going to divide by negative 374. It's going to give you a decimal, and that's acceptable. It's going to be 0.1310. Verify that you agree with me. So I'm going to bring my work over here. 0.1310 is equal to the cosine of angle f. Now that we've got that, and just as a quick reminder, by the way, make sure you go to 4 decimal places. That'll just help us to have better accuracy. Now that we have that, we work this just like we did when we initially learned about our trig ratios. We're going to go ahead and use an inverse function to find the angle. So the cosine inverse of 0.1310 will allow us to find angle f. And if we calculate that, we will find that angle f is 82.47 degrees. And the reason why now I'm no longer going to 4 decimal places is because the directions did say to round to the nearest hundredths. So I'm going to go 4 decimal places while I'm showing my work just for accuracy, but then at the end I do want to round accurately. Okay, example 2 says to solve the triangle. So let's start by setting up and choosing the formula that we're going to use. This triangle is named triangle ABC, and we're given 3 side lengths. So because we want to solve this, we need to find all 3 angles. So we need to find angle A, angle B, and angle C. Well, we're going to repeat exactly what we just did for example 1. So let's first start by finding angle A, for example. Well, if I want to find angle A, that means my formula needs to include the cosine of A. So if I go way over here at the beginning, that means my letter that goes here has to be the side length opposite angle A. Well, that's A squared. And then we use the square of the other two sides, in this case B squared plus C squared, and then we take away 2 times whatever these two lengths are. So B times C. So remember, 2 times B times C times the cosine of A. Those are all being multiplied. Well, now what are the side lengths? Well, angle A is here, so the side length opposite is lowercase a. Angle C is here, so 6 must be lowercase c. And angle B, here we are. Okay, what I'd like you to do right now is pause the video, and I want you to repeat the steps that you used in example 1. After you're done, I want you to see if you agree with me, and if you don't, try and find your mistake. Okay, so if you simplified and solved that equation, you should have found that angle A is 137.00 degrees. The reason why we're including the 0.00 degrees is because it didn't specify how to round, so we're going to assume it means to round to the nearest hundredths. If you look at this and you did not get 137 degrees, please walk yourself through the steps that I just took and locate your mistake. If you can't fix your mistake, please make a note of that in your annotations, and we'll talk about that again tomorrow. Alright, now I'm going to go ahead and look for another angle. So you can take your pick. We could find angle B next, or we could find angle C next. That choice is really up to you. So I'm going to find angle B next. So if I want to find angle B, then I need to use the equation that ends with cosine of angle B. Well, I'm going to start my formula by writing B squared, because those two have to match. The angle B has to be using the side length opposite as what we're finding. So B squared equals A squared, another one of the side lengths, plus C squared, a third side length, minus 2 times, don't forget it's just these two segments, so A times C times cosine of B. Again, go ahead and pause your video and see what you can come up with. Okay, if you look at this now, you should have found that angle B is 26 degrees. So if you did not get that, follow through the steps that I just took and find your mistake and see if you can figure out where you went wrong algebraically. If you can't find it again, make a note of that in your annotations. Well, now that we know 2 of the 3 angles, any triangle has the sum of its angles adding to be 180. So if I do 180 minus 137 and minus 26 degrees, we're going to be able to find the third side length pretty quickly, and we'll find that angle C is 17 degrees. So now that we've learned about the law of cosines, go ahead and try the You Try Now at the bottom of the page and check your answers. If you're unable to get either of those, please let me know, and we'll talk about that more in detail tomorrow. Have a good day, and I'll see you soon.